Hello guys, and welcome to Hankins Custom Rifles, another episode of Hank's TV. Today I'm going to do a video a little bit different than my normals, and I might try to start doing these videos more often. What I've got here is a barreled action that I built back in 2017, and the customer fired his ramrod out of the barrel. So I've already checked the barrel. It has got a little bulge in it, so we're going to have to replace the barrel. And he blew the bolt face up on the Remington bolt. We're going to fix that also. Now, just for the heck of it, I took a ramrod and I weighed this ramrod, and it weighed 1,056 grains. This rod is about 4 inches longer than the rod would have been that he was shooting with this gun. So I'm just going to round that down to 1,000 grains on the ramrod. The bullet he was shooting was a 275 grain bullet. So that brings our total weight of our projectile at 1,275 grains. He was shooting a 78 grain load of IMR 4198, which is my standard recommended load. And when it went off, it blew the primer pocket out of the primer. I'm going to bring this in here and show you all up close. It blew his bolt face up and blew the extractor out. So I'm going to bring this in so that you guys can see this. This is the module that is blown up. This piece right here is the extractor that came out of the bolt. And then this is the bolt face. I'm going to stand right in front like this so maybe it'll focus better. This is our bolt face, and I'm going to go in there and weld up what's missing. If I have to weld it, I may get by without welding anything. And we're going to put in a Sako Extractor and fix that problem. Here's the primer module, and you can see what it did to that primer module. Now, a lot of guys out there now are starting to say that you want to buy these aluminum bronze modules that are being made, and I make them. I don't really recommend them for this simple reason. If this had been an aluminum bronze module, it would not have blown the primer pocket out, it would have not swelled up, and it would not have acted as a pressure relief valve. Therefore, since this barrel is already bulged, and I checked that by pushing the bullet down it, and it goes about halfway down and then the bullet just falls through. Had this primer module not have acted as that relief valve, and you had an aluminum bronze primer module in there, most likely this barrel would have shattered, disintegrated, catastrophic failure, and the guy shooting the gun could have gotten hurt really bad. So I highly recommend you guys, when you buy these ignition systems, to buy the brass, standard brass primer modules. These things will hold 56,000 psi, and if you're going over that and you're blowing your primer modules, it's a very good telltale sign that your pressure limits are too high. There are some exceptions for needing an aluminum bronze module, and I'm not going to get into those on this video because that's not what this video is about. But just stick with the standard brass primer modules, and you're going to be on a much safer level if something was to go wrong. But anyway, we're going to move on into this video, and what we're going to do is I'm going to show you how I put in a Sako Extractor, and that's what we're going to do mainly with this video. We're not going to do any barrel work or nothing like that. It's just going to be the Sako Extractor. The barrel work will be a separate video at a later date. So let's move on and let's get set up to fix this problem here on the Sako Extractor. Okay, so we're down here at the lathe, and the first thing we've got to do is set the bolt up in the lathe and get ready to machine the face of the bolt and the blowed out rim. I'm hoping that there's enough rim of that left that I do not have to do any welding on it. But if we have to weld it up, we'll have to weld it up and machine it back down. So here's a fixture that I made probably close to 20 years ago. I don't know how many Sako Extractors and actions that I have used this fixture on for blueprinting and stuff like that, but I have literally put in hundreds of Sako Extractors. with this fixture. You can buy these from Brownells now, but back in the day when I was trying to buy one, you couldn't buy it. I do believe they might have them in stock now. So what we want to do is just get this thing set, being kind of close to being indicated, and then I'm going to come back and indicate it here in just a second. So we just barely tighten the jaws, and we're going to put the bolt in this fixture to hold it in place. So we've got the bolt, and we're going to set it in here, and we're just going to use these aluminum straps that I made along with the fixture, and we've got some 1/4 bolts here that's going to hold that in place. I'm going to put just enough of the head of this bolt sticking out of the fixture so that I can indicate it, get an indicator in on it. And you want to make sure that the handle is not sitting on the fixture so that you can get a true indicated bolt face. Now I'm going to reach over here and grab a 7/16 wrench, and we're just going to lightly tighten this up. And it doesn't take a whole lot to hold it because we're not going to be machining on it really hard. So we're just snugging these bolts. That'll be plenty to hold it. And now we're going to indicate. I like to have that straight up, this belly straight up with one of the jaws. It doesn't matter which jaw, but it just so happened it lined up on jaw number 1. So now we're going to take and wipe off our carriage, get that nice and clean. We're going to put our indicator on. Get it in position, and I want to ride this bolt head. Okay, so we're just going to barely ride that bolt head, and I just want to touch the bolt. Actually, that's probably would be better called the bolt body. And this is only a 4/1000 inch. 4/1000 is all you have in this indicator, so it indicates in tenths. So you want to just barely touch it. You don't want your needle to go all the way around. If it goes all the way around, just back it up and set it to where it does not go all the way around. So I'm going to tighten this jaw and bring it down a little bit. Okay, and we are still high on jaw number 1, and it's tight. So I'm going to loosen jaw number 3 just a little bit so that I can push jaw number 1 down a little bit. Okay, and now we're not touching. So we're going to come back and get another touch. Our high spot is right there, so it's still jaw number 1. We're going to loosen jaw number 3 again. Come back to jaw number 1, tighten it. Now we are within 1/1000th and a half of running true. So our high spot now is jaw 3. Tighten it up just a little. And we are within about 3/4 of 1/1000. And here's our high spot, jaw number 2, which we haven't even touched yet, so I don't want to over crank it because jaw number 4 is not tight either. So now we're going to come to jaw number 4, and it's the high spot. So we're only going to move it 1/2 thousandths at a time until we get these 2 jaws tight. 4. That one's getting tight. Now we're at jaw number 2. And that one's tight. Our high spot now is going to be jaw number 4. We're going to go 2/10. And our jaw now is number 1, is the highest spot. 1 is still high. Okay, and I'm going to call that good, fellas. We're within about 2/10. And you got to remember, when you're indicating this stuff in, stuff is not always perfectly round. And when you're using a 1/10 indicator, it will show up stuff that's not round. You'll sit there and you'll try and you'll try and you'll try, and you never can get it indicated because your part's not round. So you have to just give yourself a tolerance. What you can accept on a particular job. Is your part round? Is it worn? And you can actually see on this bolt face here, this was an old bolt, old Remington 700 that's been used and cycled who knows how many times. The bluing is worn off. So you got to think to yourself, is this part really round? Am I going to sit here forever trying to get this thing indicated to where it's perfect, no needle movement? You can't do it. Even on your brand new custom high grade barrels, when you're indicating on the outside to get yourself close, most of them aren't round. You get a harmonics going on while they're being turned, and they don't turn out round. So I'm going to bring you in real quick, show you this needle moving so that you can see what 2/10 of a thousandths looks like on the video camera. Okay, so we're looking straight down into the lathe here, straight down onto this bolt. And I'm going to rotate the chuck, and you can see the movement on that needle. So right there we was almost at 2.5, and here we're at almost, it's less than 2/10 out. So I'm definitely going to call that good for what we're doing. So we're going to go back to the tripod with the video camera, and I'll show you what the next step is. Okay, so we're back to the lathe. We're ready to start the next step. First thing I'm going to do is remove my indicator. Put it over here on my metal shelf so that it doesn't get knocked over. And if you've never put a Sako extractor in, or if you guys don't understand or just don't know what a Sako extractor is, it's just a different style of extractor that it's a great improvement over the factory Remington extractor. So whenever a Remington extractor goes bad, I don't even attempt to put in another Remington extractor. I just go straight for the Sako, fix the problem once and for all, and be done with it. Now, it does require some soldering on the bolt. It must be soldered in. I've seen people put these in, they glue them in with a 2-part epoxy, let it dry overnight, come back the next day and machine it. I can promise you that that's not going to hold. It's just not going to stay there forever. It might last for a long, long time, but over time, solvents will get down in between the epoxies and it'll release the grip, and this little ring that you've made and put in here and machined to fit is going to come loose and come out. I have fixed several over the years where people have put them in with glue of some kind. So first thing we got to do is go in here and machine this pocket, the bolt recess I should call it. We got to machine it so that this fits in here. Now I've got these little rings made up, and I've made these out of a old chrome moly rifle barrel of some kind, whatever I had laying around at the time. And I set my machine up, and I probably made 100 of these. I've got a drawer full of them. I made it small enough so that it'll work for a 223 cartridge, and it can be bored out to work all the way up to a Magnum cartridge. So I only had to make one size of these, and I keep them in a little drawer. Whenever I need them, I can just go grab one. So the first thing we've got to do is get this rivet out. There's a rivet right here, and we want to get that out, and I'm going to do that with a little hand drill and a center drill. So we're going to get a little cordless hand drill. Okay, so here's the drill we're going to use. This is the center drill, and you want to make sure you pick out a small one. You don't want a great big center on the end, and all you want to do is drill the head off of this rivet. And you can do that carefully by hand. Just keep your drill right there keep your drill in the center of the head. And as soon as you break the head off, you can tell. Okay, so that head is gone. Now the next thing we're going to do is get a small punch and a hammer, but sometimes you don't even need the hammer. All you got to do is push down on that, and now that head fell out and what's left of the extractor. So I don't know if you guys can see that, but that's all that's left of the Sako extractor head. Just a piece of garbage. We can throw that away. We don't need the hammer. So, and that's all we're going to need the punch for. I'm going to look around in there, make sure there's nothing else in this way. And now we're ready to start machining. So the first thing is we're going to take this small carbide boring bar. I use this a lot. This is a really good carbide boring bar. Get them from Micro 100. We're going to come over here and we're going to roll in until we touch the face of this bolt. Just want to barely touch the face. You don't want to hit the face real hard or you'll chip your carbide boring bar. And then I'm going to hit the 0 on my Z-axis. You can't see that in the camera because I'm trying to keep you focused down here where you can see what's going on. But we hit the 0 on the Z, and now we're going to come in and we're going to start machining this out. And I'm going to try to move the camera around so that you guys can see this operation a little better. Okay guys, we're set back up now with the video camera. I moved it to a different position. I've got it sitting on the back side of the lathe so that you guys can get in here and actually see where the cutter's going to be doing the work at. This little boring bar here is a very valuable tool and I use it quite a lot. So we've already set the 0, how deep we want to bore, and it's very important to bore only to 0. Don't overshoot your number none. I will usually stay about a 1/2 thousandths off of the number, and then on my very last pass I'll take it all the way and then do a sweep across the face to clean that all up. So let's go in there and let's start cutting that out. And what we're going to do is we're going to cut it out just big enough for this ring to sit in there. So once we've got this ring sitting in it, that is the dimension that we want to get to. Now I could measure this ring and bore it to that measurement, but I don't even know what that ring measures right now because I haven't measured one in a long time. So let's go ahead and start cutting this. Check my gears on the machine, make sure I'm in the right gear, speed and feed and everything's looking good. Okay, I've done enough of these to know that we're getting close to fitting, but I know that it's not going to quite fit. But we can check it just to be sure. And we're going to keep machining. It looks like I'm going to get all this cleaned up. The part that was blowed off is not going to have to be welded and cleaned up. And then remember that you got to take very, very light cuts with this small boring bar. This is only an 1/8 inch diameter on the boring bar. So if you take too big of a cut, it'll break it off. And these bolts are pretty hard. This bolt face is pretty hard. It's probably made out of a 4140 or 4130 chrome moly. and heat treated, so very light cuts. So now we know we're getting close. I'm going to start checking it every time I make a pass. Okay, and so far I haven't even looked at my digital readout to see how deep I'm going. I'm just boring to what I call the bottom. And on my very last pass, I'll look up at the digital readout and take it to the 0. Now you might be able to hear it on the camera that there is an interrupted cut in there. And there's 2 reasons for the interruption. One, we've got this hole drilled through the center that held in the factory extractor. And 2, there's a big undercut in here, which we have gotten removed. Most of the time that does not get completely cut out, but this time we did. And that will cause an interrupted cut. But we are big enough now that I can force this to drop in there. I don't want to force it in. I want it to just be able to fall in nice and easy. So this is going to be my last cut. I'm just going to take maybe 2/1000ths of an inch off that last pass. I'm going to go all the way to 0, and then I'm going to walk across the face to clean up that bolt. Digital readout and go to 0. And we cleaned that up all the way across. So now you can see how nice and clean that is in there. Can blow out the chips. And this little ring that we've got made should fall right in place, and it does. All right, now that's about perfect. Now the next step is to solder this ring inside this bolt. And I'm going to set up and show you how I do that. We have to tin it. Both of these pieces has to be tinned with solder first. And it's kind of a tedious thing to do. It's not that hard. You just have to realize and understand what you're doing when you're tinning these parts, that once the solder flows out and sticks to the part, then it is properly tinned. If you just try to melt the solder on top of these pieces, the solder just keeps falling off. So you have to use flux and the proper solder, and the temperature has to be just right, and the whole 9 yards. You got to get everything right, or else it will not work. And we're going to start by tinning this little ring first. So let's move on over to the vise, and I'm going to show you how I do that.